Now there's a particular component of the Nexus-based data center architecture that really does deserve some special scrutiny. Join me in this particular nugget as we take a detailed look at the Cisco Nexus 2232 10 gigabit Ethernet fabric extender. In this nugget, we'll break down our close exploration by reviewing and discussing some of the benefits that the 2232 is going to bring to our infrastructure. We'll talk about connectivity to the parent 5500, and then we'll talk about something called adapter FEX and how this would be set up and verified. Now, two massive benefits that I want you to focus on when you think about the fabric extension infrastructure. The first massive benefit is indeed scalability. Massively so. Scalability is brought to the equation here. Think about it. You can have one of these 2000 fabric extenders accommodating up to 32 physical servers. Now you might say, well, that's not all that huge, but think about it. Those 32 physical servers can be hosting many different VMs. Yeah, the exact number per physical server will certainly vary based on how we've provisioned the server hardware, but really this starts to become very, very impressive when you think about it. 32 physical servers for each FEX, each of those physical servers having many, many VMs potentially. Now, how many 2000 series FEXs can you accommodate for the 5000 series? Well, it depends on the exact way you've got your hardware configured, specifically whether you're using a layer 3 line card or not, but just suffice it to say that we can have 8 to 24 of these FEXs. So imagine a 24 FEX environment, each hosting 32 physical servers, each hosting, let's say, 5 VMs. The scalability starts to become very, very impressive indeed. Now, another massive benefit that I want you to keep in mind is cabling. Yeah, absolutely. The utilization of this FEX design gives us short intra-rack runs of copper that we can utilize, going from the 2000 series down to the actual servers themselves. That's our top of rack type cabling. And then for our inter-rack cabling, for our 5000s that are located either mid or end of rack, we'll use longer horizontal runs of fiber connectivity. So we have a nice flexibility, a very efficient cabling model when we consider this fabric extension design and implementation. Now let's talk about some potential deployment models for the FEX. One deployment model, and I'm going to write this out for you, very important that you get this terminology. It's called the straight going to be dynamic pinning. What we do now is we take these links between the 5K and the 2K and we bundle them together. Obviously now the traffic from this C-Series device is going to end up somewhere in the particular bundle of links, and that'll be handled by the particular hashing algorithm that is used inside the port channel. And that, of course, brings us to our third option. What is the third option? It's to go ahead and do what's called active pinning, and we do this by increasing the scalability here dramatically. So what we do is we have a couple of 5Ks, we have a couple of FEXs. So we'll say the 2K here, the 2K here, and what we do in this environment is and let's just focus on one of the 2Ks, right? We connect it to the two upstream 5Ks, and we go ahead and do our virtual port channel technology. Obviously, if you introduce another 2K, you'd do the same thing over there. Bottom line is we have active upstream 5Ks, and think about a server now. Think about a C-series server in this environment. That traffic is going to go wherever it needs to go upstream in the virtual port channel. In other words, if there was a problem here, the virtual port channel would handle that and start sending everything that way. So, 3 models, and I want you to realize that some of the hardware can only support certain models. For example, when we're talking about a Nexus 7K northbound upstream, it can only do option number 2. It can only do straight through with dynamic pinning. But if we're talking about the 5Ks, as we've alluded to, they can do the sophisticated active option 3. So just be aware of these 3 different design deployment models for our FEX, and keep in mind that they are going to be dependent on the particular hardware you're implementing. Now please, this will really be the second time in the course we detail for this for you. Remember how this adapter FEX concept works. Remember now, we have a parent 5K. The actual physical interface that is going to make connectivity to a particular server is down on the 2K. What we do is we have a logical interface on the 5K that is going to make that association with its remote K, with its remote 2K physical interface. You'll often see this referred to as the host interface. Okay, so this actual physical interface we'll call the host interface a lot of times. Do you remember the technology that is added to the particular packet between these devices? It's the VN tag technology. The VN tag is added to the packet, and this can be extended, this VN tag concept, all the way down to the C-series device, remember, if we are using a virtual interface card. So this VN tagging is indeed our new technology that will allow for this to network forwarding, or you'll see a 1 in that field if we're talking about network to host forwarding. There's a P bit. This is the pointer bit, and this will be set if you're dealing with a multicast frame that requires egress replication. So let me just label this as the pointer bit. And then finally, there's a looped bit. The looped bit or looped filter is set if we're sending back to a source Cisco Nexus 2K series fabric extender. Also, by the way, we have source and destination virtual interface fields. So let me label this. This is our looped filter. And then finally, we have our VIF fields inside this particular tag. And what this is going to do is provide us the destination virtual interface, and the source virtual interface. So there you go, a look inside the VN tag. I've probably gone a little bit deeper here than would be required typically in this certification environment, but as you know, that's been my theme throughout this course, to really make sure we kind of stand on the shoulders of the exam and reach a bit higher, if you will. Now, how is this verified? Well, when you're on your 5K, you can go ahead and issue your show interface brief command. And what you can do is under the mode column, where you normally see like access as the mode for each of your ports, if you see the mode as fabric, this is your verification that you are dealing with a FEX fabric interface. That's right. That interface that's listed as fabric on that local 5K is one of our FEX interfaces down to the Nexus 2K. If you need more information about the fabric extension setup, Cisco does provide us with show FEX and show FEX detail. So we can explore in greater detail the configuration of the FEX, including things like the state of both the physical and the logical interfaces, as well as the particular pinning mode that we are utilizing. Remember those, straight through static, straight through dynamic, or our active setup. Well, do you think we would find information about this exciting data center technology in the exam environment? The answer, of course we would. What type of interface on the Nexus 5K is used with FEX? Is it VIF, VN tag, FEX-INT? My goodness, it is indeed the logical interface that we find on the 5K that maps down to what we say is the physical interface on the 2K. We'll often refer to that, by the way, as the host interface. Great work. So thank you for joining me, really, in this elaboration on an important concept. The fabric extension concept in the data center, starring the Cisco Nexus 2232. We took a look at the wonderful benefits of doing this. We talked about the ways in which we can implement it, our straight through static, straight through dynamic, or active pinning approaches. And then we elaborated a bit on that concept of adapter fabric extension, taking a particular detailed look at the VN tag that is utilized in that infrastructure. I certainly hope this nugget has been informative for you, and I'd like to thank you for viewing.